In this poster, we have designed the asymmetric donors and single acceptor-based molecular system to harness triplet excitons via different methods. We introduced two angularly oriented carbazole units in the acceptor part to harness thermally activated delayed fluorescence, while two lone pair of electrons containing phenoxy ring donor systems to harness triplet excitons via room temperature phosphorescence emission. We studied the molecules in different mediums like solutions, polymethyl methacrylate film, DPPO film, and concluded via time-resolved emission studies that thermally activated delayed fluorescence is observed from the lower charge transfer state, while RTP is observed from the higher lying locally excited triplet state. We concluded from photophysical studies of different films and while time-resolved emission studies that the specific introduction of the donors of different strength in a single molecule at different positions can lead to the emission from two different channels in a single molecule.
A Frenkel-Holstein approach to describe the evolution between structured and unstructured excimer emission. Collective screening phenomena prompt free carrier release in doped organic semiconductors.
Good afternoon. Firstly, I would like to thank the organizers for giving me this opportunity to present our recent work, which is focused on the analysis of exciton states of large aggregate of PBI, perolenbizimide. We employed two approaches. The first one is a diabetization procedure applied to full aggregate calculations. Secondly, as a cost-effective alternative, we also propose a model Hamiltonian based only on dimers composing the aggregate. We studied the exciton states of PBI along this longitudinal translation coordinate. Both approaches provided satisfactory results regarding the energy profiles of low-lying exciton states, their charge transfer and Frenkel character, and also the unconventional charge transfer mediated J aggregation observed for small longitudinal translation suggested in literature is well reproduced. Thank you very much.
Hi, everybody. My name is Simeon Gon, and welcome to my poster. Here, we're interested in electron transfer on surfaces, specifically from photoexcited adsorbates into ferromagnetic substrates. We have created an electron transfer model which uses a Fermi-Golden rule, but generalized to K-space in a periodic simulation. We are parameterizing the model using diabatic donor-acceptor couplings taken from projection operator diabetization. This is similar to constrained DFT in that it gives you the donor-acceptor couplings. When we apply this to all the acceptor states in a band structure over K-space, we're able to get a Brillouin zone averaged electron transfer rate, which is also spin dependent. And in the end, we can then rationalize an observed spin selective electron transfer rate.
Within my PhD project, I investigated a library of different myricyanines from combinations between these donors here and the acceptors here. Using a constrained DFT or PCM approach, I could reproduce the geometries of the myricyanines from the solid state. Further, then consequently, I calculated the reorganization energies, and I get the lowest reorganization energies below 130 millielectron volts for a combination of D1A1. Then further, using again constrained DFT and a supramolecular approach, I also calculate explicitly the outer reorganization energy for the myricyanines. And then lastly, I related different solid state packing motifs, as you can see here, with the coupling integrals, and then also the charge mobility calculations and the kinetic Monte Carlo trajectories you can see here. And I could relate the different solid state packing to different directionality of the charge mobilities.
Rashba spin splitting and photocatalytic properties of GECM SSE, van der Waals heterostructures.
Hi, my name is Aslan Hepgüler from Boğaziçi University. I am going to talk about the poster with a title A Computational Approach to TADF Activity of Sulfone-Based Compounds. Thermal activated delayed fluorescence, which is utilized in third generation OLEDs, overcomes limitation of first two generations, such as low internal quantum efficiency and high production cost. In TADF, electrons are transferred from triplet to singlet excited state by reverse intersystem crossing. Small delta EST, which is the difference between triplet and singlet excited state, and small overlap between HOMO and LUMO are some of the key parameters for efficient TADF mechanism. In this study, we theoretically modeled sulfone-based compounds because it is one of the widely used moieties with its high electron accepting and transporting ability. DFT calculations are used to get a clear design strategy for sulfone-based TADF emitters.
Transport and recombination in evaporated small molecule organic solar cells.
Tuning dynamic disorder by polaronic effects in organic semiconductors.
Hello from Warsaw, my name is Adam Kubas and I am very happy to invite you to visit my poster number 41, where I will focus on the electronic coupling matrix element calculations. We probably all know that it depends on the overlap between the donor and acceptor wave functions. But what about the spin state? The literature on this is really scarce, and one of the rare examples comes from the Kevin Rosso's group. They focus on the hematite and the anisotropy of electron transfer in this material. You see on this slide that in the ferromagnetic direction, the electronic coupling is way higher than in the antiferromagnetic direction. The explanation proposed is that the low spin cations typically have smaller effective radius. But is it that simple? In our work, we found that the spin effect has multidimensional character, that it is much more complicated. We classified these effects into 3 cases. If you want to know more, please visit my poster. See you. Bye-bye.
My name is Roman Peshkov. I'm a researcher in the Laboratory of Organic Optoelectronics in Novosibirsk State University, Russia. Our lab's topic is organic luminescent compounds with spiroconjugated moiety, as far as we believe such compounds bear a great potential in the field of organic semiconductor materials. That's why we decided to prepare DFT benchmark for the simplest representative of such compounds, Spiro-4,4 nonatetraene, in terms of geometrical frequential parameters and excited state energies. We tested 12 common DFT functionals and Hartree-Fock method and compared the geometries obtained to X-ray data and IR spectra found in the literature to show that Hartree-Fock method is the best predictor of both types of properties. With the optimized geometry in hand, we tested the same set of functionals to estimate excited state energies and had shown that singlet excited states are better predicted by the functionals with more precisely described long-range correlation term, such as Cambi-Thurlip, Omega B97XD, and M062X. Meanwhile, triplet states are better predicted by Bethurlip and PBE0. Thank you for your attention.
Hello, this is Felix Plasser from Loughborough University. In my poster, I want to explain to you how we can assign the excited state character of an excited state in a molecular system without actually looking at the orbitals. First, I will start talking to you about push-pull systems. How can we know if we have locally excited states or charge transfer states or any mix between them? Then I'll move on to transition metal complexes. We'll discuss metal to ligand charge transfer, ligand-centered character, and so on. Again, how can you quantify this? By just pressing a button. Finally, I'll talk to you about the software. We've been developing tools for the last 10 years. A large number of quantum chemistry codes are available. Also, most common excited state quantum chemistry methods are interfaced. Okay, thank you, and I look forward to talking to you.
Hello, everyone. In this poster, I'm presenting our theoretical study of excited state dynamics in isolated pentacene and pentacene on a silver substrate. We used time-resolved momentum microscopy in order to obtain features of this system and in the end get photoelectron momentum maps. We can then use these photoelectron momentum maps and give an explanation of experimentally obtained features on a bilayer pentacene on a silver substrate, which was measured at flash. And our theory is able to explain additional features which result due to the substrate in these photoelectron momentum maps. And we are also able to explain time-dependent measurement where we see a geometry relaxation of an excited pentacene. And if you want to know more, you're welcome to visit the poster. Thank you.
Hello, my name is Shapovalov Kirill. I am a PhD student in Organic Optoelectronics Lab of Novosibirsk State University. Recent time, spiroaromatic compounds became attractive as perspective materials for light-emitting devices. Currently, literature mainly concerns spirobifluorine derivatives, so we decided to investigate spiro-nonyltetraene-based derivatives with different number of condensate benzene rings. So we made assessment of charge carrier mobilities and triplet exciton mobilities via reorganization energy by Marcus theory. We found out that the highest electron and hole mobility is for more aromatic compound, and the highest triplet exciton mobilities for quinoid compounds.
Edge and surface functionalization of prolonged graphene nanoribbon.
Hi, my name is Pelin Ulukan. I am from Boğaziçi University. In this poster, I'm going to present my study about descriptive analysis in thermally actuated delayed fluorescence technology. TADF is known as the third generation OLEDs and are very popular with their purely organic nature and high internal quantum efficiencies in device applications. This generation is mainly controlled by the reverse intersystem crossing of excitons from T1 to S1 state, and as this reverse intersystem crossing increases, TADF activity increases too. In this study, we are focused on the boron-based TADF materials. We choose boron because with the help of its vacant p orbital, it contributes to pi conjugation in organic materials, making it a suitable material in organic optoelectronic applications. Herein, we did a theoretical study to understand the correlation between molecular structure and TADF activity.
Hello, this is Bingjun Wang from University of Oxford. Today I'm happy to talk about our recent work about chain conformation control of a fluorine benzyl thiodiazole copolymer for improved LED performance and lifetime. We generated a particular microstructure called the beta phase, in which the intermonomer torsion angle is 180 degrees, in a copolymer consisting of 90% F8 units and 10% BT units. We observed that LEDs with this beta phase showed improved performance in terms of luminance, external quantum efficiency, luminous efficiency, luminous power efficiency, and operational stability. The basis of these enhancements was studied in detail, and it was found that an increase in hole mobility leading to correspondingly more balanced charge transport, lowering of the hole injection barrier, and a reduced trap density during device operation all contribute. Thank you very much.
Hello, I am Zuzana Totsulova from the University of Oxford, and I would like to introduce our droplet on hydrogel bilayer-based assay for high-resolution optical studies of membrane proteins in energized lipid membranes. In our assay, the lipid membrane is supported by a thin layer of agarose, which guarantees stability, hydration, and accessibility of the membrane, mimicking protein's native lipid environment. We use complementary charged proteoliposomes for delivering proteins into the membrane. Our protein of interest is molecular motor ATP synthase, but the assay is suitable for functional study of various membrane proteins, especially if they require transmembrane potential for their function.
Hello, I am Smruti. Currently, I am working as a postdoc research fellow with Professor Charles Patterson in Trinity College Dublin, Ireland. Last year in 2020, I got my PhD degree from IIT ISM Dhanbad, India. In my doctoral research, while working with Professor Sridhar Sahu, my focus was on the theoretical study of organic semiconductors and their charge transport and optoelectronic properties. In addition to this, we have also focused on different aspects of organic semiconductors such as charge mobility, air stability, and N-type characteristics. In this international workshop, I am going to present on the topic charge transport properties of air-stable organic semiconductors. Thank you very much.
Designing a mechanically driven spin crossover molecular switch via organic embedding.
Impact of nanoscale morphology on charge carrier delocalization and mobility in an organic semiconductor.
I'm going to be presenting our results on learning high-level expensive lattice energies from the low-level chip force field in a hierarchical manner called delta machine learning. Having access to high-level landscapes, typically hybrid functional DFT, is critical for identifying polymorphs of molecular crystals, especially those systems in which weak forces like hydrogen bonding determine the crystal structure. Here we start by minimizing the cost of data collection, and then we train a machine learning model on the difference of 3 levels of theory. Finally, we showed that the whole high-level landscape can be reproduced with a fraction of the original cost, which actually goes to the data collection part. I'm looking forward to discussing these ideas with you during the poster session.